thousands of blocks by this means. So they had that. They also had the shadoof, which was a counterbalanced weight that lifted water from the river into drainage canals. So they were using balance and counterbalance. And again, we knew the Egyptians had a knowledge of this. They weighed things regularly. We know they had ropes, and we know they had these little sleds. These have been found. So putting all these together, it's not too much of a stretch of the imagination to see how this would have been arranged. Pyramids are not objects. They're major civil engineering features, and as such, the construction of them would have required an immense amount of control. It's necessary when moving objects of any sort that you know exactly how much they're going to move with a given amount of force. Things have to be under control, because if they're not under control, they're out of control. There's a dotted line relationship between inefficiency and ineffectiveness. If you do something 4 or 5 times with a lot of effort, maybe you can make it work, but not 999 times out of 1,000. You're asking for trouble. So their techniques would have had to have been as reliable as we cash checks. They knew how to move these things reliably. By this means, the project would have flowed together. And this is important because although a pyramid's a very simple, recognizable object, the site itself is more reminiscent of a bullseye, because most of the people would not have actually been working on the monument at any one time. They would have been in the periphery, quarrying stones, transporting them, dressing them, preparing food, beer, and so a limited number of men in select teams would have been used to actually transport the stones from a staging area to the working platform, and then specialized teams who knew exactly how to place the stones under the direction of the engineer. Shortly we will be building a larger pyramid. The advantage of this one is, well, it contains approximately 8,000 blocks, and it facilitates a more complicated internal architecture, and it will allow us to demonstrate how the blocks were raised to the higher levels, and how some of the larger, heavier blocks, non-standard in dimensions, were raised into the upper reaches of the pyramid, especially the pyramidion block, which went right to the top. The other advantage of the larger pyramid is it allows us to section it and show the internal structures, and also how all the blocks are put together. All of these models, of course, will be available. They can be supplied to order. Initially, we hope to build the bigger ones, because they do show a lot more. They're far better at demonstrating the structure of the pyramid and how they were constructed. These also feature the light shafts. There were shafts that went from the burial chamber to the outer parts of the pyramid. These are all faithfully reproduced, and it's possible to shine laser lights down them and bounce them off and come through the opposite channel. Not strictly accurate, but good theatre. You know, the rocks you see in various parts of the States and around the world where there's limestone, they usually come in blocks. Sometimes they're quite thick, sometimes they're quite thin. And in between, they come apart, and that's because there are minerals inside that don't compress. And that mineral has plate-like qualities. And when it's mixed with water, it's very, very slippy. You ask anyone who has done pottery, who made pots, and you'll find that that clay that they make pots with is very, very slippy. You get some on the floor and step on it, boy, you're in trouble. It's better than a banana skin. And I think that kind of a mineral would have been more effective at lubricating the passage of stone over stone than an oil or just water. Finally, I think none of the techniques that I've demonstrated here can be construed as eliminating any of the other systems that we know they use, such as dragging stones or hauling them on sleds. But my premise is that with a project of this size, the engineers would have based all their decisions on numbers, on how much, how long they had to do it, and not on qualitative considerations. What you do if you have to move one block is very different than if you're going to move 4,000 of them. I mean, for instance, some of the larger statues and later on the obelisks were floated down the river. They couldn't have lifted those stones onto boats. They would have had to have taken the stones over a dry dock with a ship underneath it and then flooded the dry dock and brought the ship up underneath the object and then floated it away by that means. But that would be not very efficient if you're moving thousands and thousands of blocks. It's okay if you've got one or two. You can take your time doing it. The same with building ramps and rollerways. It's only economic if you're going to use a lot of them. If you're only doing one or two, no, you just take your best shot and use as much care as you can. The model pyramid shown in the video is the original prototype, and of course the construction ramps and lifting system are hypothetical. Nonetheless, they do demonstrate the possibilities and provide a novel insight into pyramid construction and further food for thought and discussion. Now, the pyramid model itself is built from a basic interlocating block system, which has over 30 different block shapes to create the final structure. This system allows the approximation of many of the features of the Old Kingdom pyramids and mastabas. The blocks are hard, durable, and have a textured surface which exhibits the look and feel of stone. They also have some mass, around 20 plus grams per block, depending on shape and size. Accordingly, the larger pyramid models envisaged using 7,000 plus blocks would weigh in at just under 200 kilograms. The larger models do offer greater possibilities, more realistic internal structures, and allow the pyramid to be sectioned along different axes to reveal these features. It also allows the mechanism for elevation of the blocks to higher levels in the pyramid to be demonstrated. Of special interest is the raising and positioning of the capstone or pyramidion on top of the pyramid. Once built, these models can be dismantled and rebuilt like a jigsaw puzzle. The model pyramid is ideal for demonstration purposes and as a collectible for Egyptophiles. One thing can be said with certainty, that building one of these model pyramids for a few hours will give the builder a very different impression of pyramids and a profound appreciation of the structural and design difficulties faced by the ancient Egyptians in building the original monuments. Should any of the viewers have further interest in learning how the whole system was developed or have interest in buying or exhibiting one, please feel free to call me for prices, delivery schedules, exhibitions or any other points of interest. Contact information is shown at the end of this video. PS, subject to Treasury approval, construction will commence on a larger pyramid shortly. Please watch this space. Thank you.